Next demo of the evening is going to be from EidoSearch. I'd like to call David to present what he calls the Pandora of finance.
This is a tech meetup, is just to show the software itself. Now this runs over, this is a SaaS product, so it runs over the web. We can also install on the client side to bring in proprietary sets of data. But let's start with a straightforward example. Say that Alcoa is on your watch list. Okay. Here I'm pulling up Alcoa. This is the daily price history going back to 1962. Okay, it's a portfolio holding our watch list stock. Here's what has happened to Alcoa in the last 1 year. So I've just zoomed into this 1 year pattern. The question is, when you've had this sort of declining and choppy sideways behavior, what tends to happen next? So what I'm going to do is click search. Now, this formulaically is complex to describe. What most people do is the simplest possible pattern, a 2-point pattern, the momentum from the beginning to the end. We're capturing all the information in between. This is running real time, and we're looking over a large data set of individual equities. And what you have, what comes up in the list below, is a ranked list of results. Okay, so we looked across time, across industries. Now I'm going to tell you about how you can define the search space further, but let's just start with the broadest universe. Okay, the way to read this, you got symbol name, start and end date. So, matches in 03, 01, 2008. And the similarity score. That's how we measure how close is this historical match to what Alcoa has done today. Okay, now out of the box, that's correlation. Now, anybody can calculate correlation between two curves. But what we're doing is we're doing this rapidly, exhaustively over large data. That's what sets us apart. It's the search engine that allows people to explore ideas spontaneously with great efficiency. So, that table of results, let's look at it in chart form. To visually verify closeness of match. So what you have in blue is the matching portion, the historic matching portion to our original query. What you see in red is what happened after that period. So say you're a research analyst, you might find a particular analog that's relevant that can help you to create a thematic story. Now it's at your fingertips. Or take a quantitative approach and backtest the whole batch. So what I'm doing is I'm saying, 1 year out, we found a number of similar occurrences, similar circumstances. 1 year after that pattern, what tends to happen next? Okay, this is using the data to its fullest extent because it's made easy to do. This is 3 clicks, and now we have our statistics. So we have 22 results that were up following the pattern that had sufficient data for a 1 year forward-looking back test, and 18 results that were down. Okay, average return, let's go to the statistics, is 15%. On average, you're up 15% in the next period. Now, we've been tracking Alcoa. I ran this in June, in July, and at that time, Alcoa had severely underperformed the market. And a number of clients had a hunch, this isn't going to last forever, but quantify that. And so back in the summer, the signal was strong, 33, 44% up on average with a high hit ratio. Now some of that move has been taken out. Since the summer, Alcoa has been up. So this is the kind of thing where you get to the quick statistics. Now we're talking about a relatively simple example that was a one variable search. This scales up. It applies to any time series data, financial or otherwise, or any sequential data for that matter. And you can do multi-factor search. So one more example in equities, and then we can move on to something else. So here I'll show you an example of a 2-factor search. In this case, you got price on top, volume on the bottom. Here I'm grabbing that same pattern, clicking search, and in this case, we're looking at both price and volume concurrently to find similar patterns in the past. And the point is, you can look at the features where you have spikes in the beginning and spikes in the end, and capture that additional information to the extent you feel where you have a price move with greater liquidity, it's a more meaningful result. Okay, so let's take this to another level. And look at macro statistics. Okay, here's the rate of unemployment. It's been declining over the last year or so, and then rising a bit. I click search 1. In this case, you just look back along the curve and test what tends to happen to the market next after these periods of unemployment, of declining rate in unemployment. So in this case, this is a projection in terms of what statistic in this macro stat tends to come out after these periods. And here I'm testing, what does the market do? What does the S&P tend to do after these similar time frames? Okay, so you see how rapid this is. Now, what does it take today to ask and answer these questions? It's programming, which is rigid, which doesn't scale. Search looks at the features that are inherent to the data. And that's what allows for true idea exploration. John, how much time do I have? 5 minutes of Q&A or
5 minutes
presentation? Okay, great. So that's the flavor of the product. Just for comparison's sake, here's a typical query. It looks complex. It's a very simple idea. When Microsoft is up a lot in a day relative to the last 1 month, what tends to happen in the next 1 month? So you're a trader, you're looking at your screen, Microsoft spikes. Okay, either you do this coding, you spend significant time becoming proficient in a programming language and expressing the query, or you use our system. Microsoft, I'm highlighting a section, flat for a month, spiking up. Conduct your search to find this recurring pattern over time. Here are some examples. And get your quantitative statistics. Now, of course, drivers in the market change. The historical information doesn't necessarily contain all of the information. So marry this objective quantitative approach with the other things that you know. That's the most powerful way to use the data. And this democratizes, in a sense, the way analysts can approach using this historical information. Now, the same search engine can be used once you've found patterns that hold promise to then look today to find them. Use that search engine instead of looking back, look concurrently. Find relationships across stocks. Find relationships across macro stats or your own proprietary factors. Okay, for example, take asset allocation. We want to create a basket of stocks that trade sensitive to crude. You can go about this in the standard way. You come up with the list of usual suspects, Exxon, BP, or let the data tell you. Okay, so take the price of crude, search 100,000 stocks around the world, and come up with that ranked list of results. Some of these you would have anticipated. Others will be news to you. Search is about discovery. Okay, here's macroeconomic 3-factor search. Take the variables that you feel are the drivers in the market today. Not a stale research report, but what you've read in the news. And use those variables as to define a macro environment. Look back, find the similar circumstances, and then test what happens to different industries next. This is for sector rotation or asset allocation as well. Okay, so there are applications across the board, across quantitative strategies. It's the kind of tool that has deep power and speed and allows for this idea exploration that really revolutionizes the way we look for relationships in financial information. Thanks. I'm happy to take questions.
Where do you source your data from? And the second question is, what is the frequency of the time series that you use? Is it daily? Can we define our own frequency, 15 minutes, 30 minutes, or?
Yeah, we get our data from two places, either vendors, Morningstar is a vendor, so we have relationships with wholesalers of data, and from clients. To the extent they have proprietary information that others don't, it's quite valuable to search for relationships in that data. So we can pull it in and serve it back searchable. We can put an instance on the client hosted, and that combined with the data that we have is the full package. And what was the second question?
Time series frequency.
Oh, any frequency. To us, it's just points in time.
So you just have a database, you have some standard template where you fit in the data and any kind of frequency, and your application will do the search.
That's right. So we take the raw data in a standard database format. The secret sauce is where we calculate a secondary index database that sits alongside it. That's what allows for the quick search.
Understood. Thanks.
Yeah.
How successful is your search product with uncorrelated events like the death of Steve Jobs or Apple announcing a dividend?
Well, so event studies, this is a very interesting area where if you look at, there are ways to define your search space. One simple way would be full or bare environment. Let's only search in a full or only search in a bare environment. Or likewise, let's just look in the 1970s because I think that's similar from a macro perspective. Well, another way to define search space is by event. Let's make it simple. A good earnings surprise or poor earnings announcement. So screen the search space by those types of events and look for patterns going into it. Then you can backtest and see what tends to happen going out. There are psychological explanations, things like underreaction or overreaction for patterns. There are business reasons, like the business cycle, people's risk tolerance changes over time, or in your case, news event.
Well, are you also tracking other indexes or just equities, or how about E-minis or anything else?
This is a general engine, so it works on any set of data, any set of time series data. We have currency, equities, Twitter for the frequency of mention of keywords. It's more about what do you want to put it on.
Do you see people using this, or is it programs on top of your search engine?
Yeah, so there are really two. You can divide our customers into two groups. You've got people who I call explorers. You're a research analyst. You want to test a one-off idea. The VIX does something interesting, or you're creating a thematic research report. But strip away the graphical user interface, and you can use our APIs to program right to the engine and test hundreds, thousands, tens of thousands of queries. That's where you get into programmatic, say for the purpose of portfolio construction or trading. So you can use it either way.
Two questions. First of all, are there order of magnitude limits to the number of data sets that you can compare against?
No, in terms of pulling a query from one and searching in another.
Yeah, I would assume that as fundamentally you're gonna, even if you're competing indexes, at some point you're gonna have to run into fundamental computational limits if you're comparing against tens or hundreds of thousands of potential data sets.
Yeah, certainly. The size of the database matters in terms of speed and performance. Mm-hmm. Although I would look at it this way: these technologies, my partner, I didn't talk about him, but he's done content-based search. The Human Genome Project for neuroscientists with image and video search. If you look at the amount of data on YouTube or in the human genome, it's massive. And while financial data is large, it doesn't compare in terms of volume. And so these techniques scale, but no question, the bigger the database, the more processing power you need to put at it, and the smarter your algorithms have to be.
And then my second question was just, are you planning to diversify beyond the world of finance?
Definitely.
In the world of advertising, there will be a number of customers who are very excited about this kind of business.
We're very interested in that. We're a startup, so we're focused, and we're delivering. And my knowledge and my partner's knowledge is in finance, but why not apply it to smart meter data, to intelligence, to media, like you mentioned? It's a general tool.
If you wanted to know how a certain event affects, say, only cyclical names or only defensive
Yeah.
equities, can you do that? Can you slice the data that way?
Yeah, I'd like to show you maybe afterwards, but if you take Walgreens, it looks like this. Its profit metric or whatever you're looking at. So naturally, actually, you're going to pick up other companies that have the similar cyclicality. That's a lot of what patterns are about. Or take natural gas. If you have a pattern in the winter month, you might want to only look in the winter months for similar matches. It's more relevant. So the user layers that knowledge into the system in the way that they use it. Everybody puts their own imprint on it, and that's really that's the most powerful way, is the knowledge of the user plus an easy way to access relationships and data. And seasonality is one of them.
Time for one more.
One more question?
What is the infrastructure stack?
What's that?
Infrastructure stack.
Oh, it's not about the hardware. We've got this on AWS. There's nothing special about those servers. Certainly, that can improve performance as well. But really, what allows us to do this is the way that we set up the database, which is a proprietary.
So, what is the programming? What programming language you guys use, like PHP or like?
We use C. We use Java. The interface is in Flash, so it's SQL database. But the key is you got to calculate the right features and store that smartly. I guess that's it.
Thanks.
Yeah.